this lesson, you will learn about speed, and you'll be able to answer the question, how do you determine speed? Let's get started. Well, let's explore what speed is and where it comes from. Speed measures how fast something is moving. There are tools that measure speed. However, we can calculate speed indirectly by measuring distance traveled in a specified amount of time. By definition, speed is a rate comparing distance to time. Mathematically speaking, this is the equation for speed. Speed is equal to the rate of distance over time. Now let's look at this example.
A biologist measures that a Galapagos tortoise walks 3 inches in 1 second. Find its speed in inches per second. So we will use that same equation we just saw. Speed is equal to the rate of distance over time. So speed is going to be equal to, well, how far did the tortoise walk? It walked 3 inches, and how much time did it take? 1 second. So you can see, as a rate, the speed of the tortoise is 3 inches per second. So for every 1 second, the tortoise walks 3 inches. In this example, speed is represented as a unit rate because the distance, as you see in the top, is being compared to just 1 second. Speed is typically written as a unit rate. This will be helpful later in the lesson. Let's look at our lesson question. How do you determine speed? Sometimes you'll know the distance traveled over a period of time, but it's not a single unit. So far, the denominator in our speed rates has always been 1, making it easy to write the speed as a unit rate. In this part of the lesson, you'll learn to calculate speed as a unit rate when time is not 1 unit. Let's explore the concept of speed as a unit rate with this sample problem. A snowshoe hare can run up to 200 feet in 5 seconds. Find its speed in feet per second. Remember that speed is the rate of distance to time. And mathematically speaking, here is that representation as an equation that we saw earlier in this lesson. Also remember that speed is generally expressed as a unit rate. So if the time, such as we see here, 5 seconds, is not equal to 1, then we will need to divide the distance by the time in order to express the speed as a unit rate. Let's go ahead and try that. Speed is equal to the rate of distance to time. The distance is 200 feet compared to the time of 5 seconds. So we need to divide the distance by the time since the time is not equal to 1. So we take 200 and we divide it by 5. 5 goes into 20 4 times. That's 20. Subtract 0. Bring down 0. 5 times 0 is 0. Subtract, bring down. So what does that tell us? It tells us that the snowshoe hare can run at a speed of 40 feet per second. So this is how you express speed as a unit rate. You've been answering the lesson question, how do you determine speed? You've already learned how to calculate speed, such as the speed that's represented here on this speedometer. In this part of the lesson, you'll learn how to calculate speed and then convert the units. Let's explore the strategy of converting speed. Remember Reggie? You found out earlier in the lesson that he was driving at a speed of 300 kilometers per hour, and that's represented right here in this problem. We're trying to figure out what is his speed in meters per hour. You previously wrote this speed as a unit rate, but this problem is asking us for different units than the units given. We need to convert from kilometers per hour to meters per hour. In order to do this conversion, we're going to need a conversion factor. Let's look at the steps in the solution process. Step 1, write the speed as a rate. Remember, speed is the rate of distance to time. So I'm going to write the distance of 300 kilometers to time, which is 1 hour. Step 1 is complete. Step 2, write the conversion factor. Remember, when I write a conversion factor, I want the same unit diagonal from the same unit so that they will cancel each other out. So I'm going to put kilometers on the bottom. I'm going to put 1 kilometer. And remember, we're converting to meters. Well, how many meters are there in a kilometer? That would be 1,000. Now, I'm ready to do step 3. Multiply by the conversion factor and simplify. So we're going to multiply by the conversion factor. Before we do that, we can see that kilometers are going to cancel kilometers. Nothing else will cancel. Now we're ready to multiply. When you multiply by a power of 10, you just multiply the 300 by the 1, which is 300, and we add on the 3 zeros. So it becomes 300,000. The label or the unit is meters, and that's going to be over 1 times 1, which is 1, and hour is our unit. So what does this tell us? It tells us that Reggie's speed in meters per hour is that he travels 300,000 miles per hour. And this is how you convert speed. Let's look at this example of converting speed to compare. Reggie runs 330 feet in 30 seconds. His cat, Mr. Kitty, can run 1 mile in 176 seconds. Who is faster? In order to determine who is faster, we need to convert Reggie's speed and Mr. Kitty's speed to a unit rate. Once we've done that, then we can compare them. But we also need to make sure that the unit rates involve the same units of measure. In this case, we're going to make sure they're in feet per second. So let's get started with Reggie. Remember, speed is the rate of distance to time. Reggie runs 330 feet, that's the distance, in 30 seconds. Now that's not a unit rate because a unit rate has to have a denominator of 1. Now earlier in the lesson, we talked about how to convert the speed to a unit rate. You take the distance and you divide it by the time, and that gives you the speed as a unit rate. So in this case, it tells us that Reggie runs at a speed of 11 feet per second. Now let's look at Mr. Kitty. Mr. Kitty can run 1 mile in 176 seconds. Remember, speed is the rate of distance to time. So the distance is 1 mile, the time is 176 seconds. Now earlier I said in order to do a comparison we have to have the same units of measure. Well, miles per second is not the same as feet per second. So we need to do a conversion. We need to convert miles to feet using a conversion factor. So remember, when we do a conversion factor, we have to have the same unit diagonal from the same unit so they can cancel each other. So I'm going to put miles on the bottom and feet on the top. Now here it says that 1 mile is 5,280 feet. So let me put that into the conversion factor. Now we can cancel the same unit, and now we're ready to multiply. So 1 times 5,280 is 5,280. That's feet. 176 times 1 is 176 seconds. That's not a unit rate, so we need to do one more conversion. We need to divide the distance by the time, so that's going to end up equaling 30 feet per second. This is Mr. Kitty's speed as a unit rate. This is Reggie's speed as a unit rate, so now we can determine who is faster. Mr. Kitty is faster. He runs at a unit rate of 30 feet per second. He runs almost 3 times as fast as Reggie. Our lesson question is, how can you solve problems about speed? You have seen speed limit signs many times, just like the one pictured in this photograph. You've already learned how to find speed when given time and distance. In this lesson, you will solve problems that involve time, distance, and speed. Let's learn how to find equivalent rates. To find equivalent rates, multiply or divide each term of the rate by the same number. Let's put this to use with a sample problem. Here we have Kelly who can type 42 words per minute. How many words can she type in 20 minutes? Now in order to solve this problem, the first thing we do is write down the unit rate. We know that Kelly can type 42 words per minute. So that's 42 words in 1 minute. That's what she can type. That's what we know. We're trying to figure out how many words that she can type in 20 minutes. You'll notice that I set up this ratio on the right side the same way I set it up on the left side. We have words on top and minutes on the bottom. So next we're going to look at the denominators. We have 1 minute to 20 minutes. Well, how did I get from 1 minute to 20 minutes? I multiplied by 20. And whatever I do to the bottom, I have to do to the top to keep the ratios equivalent. So I multiply the top by 20. So let me do that real quick over here on the side. 42 times 20, 2 times 0 is 0, 4 times 0 is 0, automatic placeholder. 2 times 2 is 4, 4 times 2 is 8, so that would equal 840. So this tells us that Kelly can type 840 words in 20 minutes. And this is how you find equivalent rates. Let's get started by reviewing speed. Speed is a rate comparing distance to time. Here we have the speed formula. Speed equals distance over time. Now we're going to use that formula in order to answer the sample problem here on the right side of the screen. The Perez family drove 550 miles in 11 hours. What was their average speed? Well, what are we solving for? We're solving for speed. That is the unknown. So I'm going to say S is the unknown. It represents speed. Speed is going to equal distance over time. Distance. How far did they travel? Well, we know that they traveled 550 miles. Over time, how much time did it take them? It took them 11 hours to travel the 550 miles. So the next step is to take the 550 miles and divide it by 11, and you would get 50 miles per hour, which is their average speed. So this is what we know now. We know the Perez family, their average speed was 50 miles per hour. So this is how you can use the speed formula to solve a problem. Let's learn how to solve for time. Janice jogs at a speed of 9 kilometers per hour. If she jogged 27 kilometers on Tuesday, how many hours did she jog? Now, in order to answer this question, we need to use the speed formula which we've seen before. Speed equals distance over time. Do we know Janice's speed? Sure. It's 9 kilometers per hour. And we're going to set that equal to another ratio of distance over time. Do we know the distance? Sure. It's 27 kilometers. But do we know the time? No, because we want to know how many hours did she jog. So in order to solve for time, we look at the ratio and how they're set up. Well, how did I get from 9 kilometers to 27 kilometers? Well, I multiplied by 3. And in order to keep the ratios equivalent, whatever I multiply the numerator by, I need to multiply the denominator by. So I'm going to multiply the denominator by 3 also. So 1 times 3 is 3. So that tells me that it took Janice 3 hours to jog 27 kilometers. And so that answers our question, how many hours did she jog? This is how you solve for time. Let's learn how to solve for distance. Here we have Javier. He drove 8 hours to get to his aunt's house. He drove at an average speed of 63 miles per hour. How far did Javier drive? Now, in order to solve this problem, we're going to use that same speed formula. Speed equals distance over time. Do we know Javier's speed? Sure. He drove at an average speed of 63 miles per hour. So we write down 63 miles over 1 hour. And that's his average speed. That has to equal distance over time. Do we know Javier's distance? No. That's what we're trying to solve for. How far did Javier drive? Do we know the time? Sure. He drove 8 hours to get to his aunt's house. So I'll put that on the bottom of the ratio because hours is across from hours. Now how do I get from 1 hour to 8 hours? Well, I multiply by 8. And in order to keep the ratios equivalent, whatever I do to the bottom, I do to the top. So I'm going to multiply 63 by 8. Let me do that on the side real quick here. 63 times 8. 8 times 3 is 24. Carry the 2. 8 times 6 is 48 plus 2 is 50. So now we know that Javier drove 504 miles in that 8 hours. So that answers the question, how far did Javier drive? This is how to solve for distance. Let's learn about hungry bugs. 2 bugs crawl toward a pile of food. Bug A crawls 4.5 inches in 2 seconds. Bug B crawls 6 inches in 3 seconds. Which bug will be the first to reach the food? Now, in order to solve this problem, let's make a plan. First thing we need to do is identify each bug's rate of speed. After that, we will convert it to a unit rate of speed. We'll compare the 2 units rates of speed, and the bug with the greater unit rate of speed is going to reach the food first. Let's get started with bug A. Bug A crawls 4.5 inches in 2 seconds. This is its rate of speed. We're going to convert that to a unit rate of speed. Remember, with a unit rate, your denominator is always 1. So how do we get from 2 seconds to 1 second? We divide it by 2. And whatever we do to the denominator, we do to the numerator. So we're going to divide by 2. So 4.5 divided by 2 is going to be 2.25. So this tells us that bug A crawls 2.25 inches per every 1 second. That's the unit rate. Let's look at bug B. Bug B crawls 6 inches in 3 seconds. We need to convert that to a unit rate. Remember, with a unit rate, denominator is 1. How do we get from 3 to 1? We divide it by 3. Same thing. Whatever you do to the denominator, you do to the numerator. So we're going to divide by 3. 6 divided by 3 is 2. So what does that tell us? It's the unit rate of 2 inches for every 1 second. Now we're going to compare the two unit rates of speed. Bug A is at 2.25. Bug B is at 2. Which one is greater? It's bug A. So bug A will get to the food first. Let's look at our lesson question. How can you solve problems about speed? You have learned how to solve for time or distance. You have also learned how to find and compare speeds of different objects. Let's look at our lesson goals and key concepts. Our main lesson goal is to learn about the relationships between speed, distance, and time. Now, in order to achieve this goal, first, we learned how to calculate time given speed and distance. Second, we learned how to calculate distance given speed and time. And third, we learned how to calculate and compare speeds when given times and distances. Remember, speed is a rate comparing distance to time. Let's look at our key concepts. The first one is the speed formula. Speed equals distance over time. The second key concept, to find speed, time, or distance, use equivalent rates to help you solve for the unknown number. Let's use those key concepts in order to solve this problem on the right side of your screen. An ant walks 3 inches in 10 seconds. How far can it walk in 60 seconds? Now, in order to solve this problem, we are going to use the speed formula. Speed equals distance over time. What is the ant's speed? Well, the ant walks 3 inches for every 10 seconds. That's the speed. On the right side of the formula, we have distance over time. Do we know the distance? No, that's the unknown. But the time is 60 seconds. Now we're ready to solve for the unknown. How did we get from 10 seconds to 60? Well, we multiplied by 6. And in order to keep the ratios equivalent, whenever we multiply the bottom by, we multiply the top by. So we're also going to multiply the top by 6. So 3 times 6 is 18. That's 18 inches. So what does this tell us? It tells us that the ant can walk 18 inches in 60 seconds.